Okay, this is homework U6B. I kind of went out of order. U6A will be on the next notes. So this is our first homework from Unit 6, solving quadratic equations by factoring. You'll notice that these are already factored, so you don't have to factor. It's set it equals 0, so we are going to be on step 3, which is to set each factor equal to 0. I'm actually going to switch to a pen because there's stuff on the back of this. So let me get a pen. All right, so if you subtract 1, one answer is k equals -1. If you add 5, one answer is 5. Those are your answers. This one's already factored. Set equal to 0. Set any factor that has a variable equal to 0. So in this first one, we're going to subtract 1. In this one, we're going to subtract 2. Answers. So you'll notice that if it's a +1 factor, your answer will be the opposite, -1. If it's a +2 factor, the answer is -2. And I'll do this one on the calculator. You can always do these on the calculator by the 0 kind of takes the place of a y. So if you type this in, I would type in parentheses. Now I'm not going to type in an a because I'm going to type in an x. X plus 1 parenthesis, open it, do another parenthesis, and then x plus 2. And if you graph this under Zoom 6, make sure you're on the screen, you'll see that it crosses at -2 and -1. Do you guys see that? If you can't see it, maybe you can go Zoom 4, press Zoom 4. It gives you a closer look. It goes through -2 and -1. Those are your answers. See where it crosses the x-axis? These are called x-intercepts. They're also called zeros of the function, -2 and -1. And this is just one way of doing it, is by solving by factoring, setting each factor equal to 0 to get those answers. So this is the algebra way, and then you got the graphing calculator way. So on this one, we're going to set each factor that contains the variable equal to 0. So in this first one, we got to get rid of the 5. Whenever there's a number out front, one of your answers will be a fraction, and it'll be this one. This one will be a fraction. Whenever there's a number out front, you're going to take the opposite of this number, which is -5, and it's going to be divided by that outside number there. So your answer is -5/4. When you do these enough, you can kind of just look at these. Opposite of 5 is -5/4. This one will not have a fraction because there's no coefficient in front of k. Do you have a lot of kids out today?
So far, yeah.
So that's why I'm doing videos. I'm like, don't even come to me anymore. Here's the video. K equals -1. So this one, these are factored. Now these should both be fractions because there's numbers in front. When you get good at this, you can just do it without doing all this work. So for this first one, it's going to be the opposite of this number divided by this number. So this answer should be -3/2. And this one should be -3/4. But this, to do that by algebra techniques, it's this. So to solve for m, we're going to subtract 3. And we're going to divide by 2. So m equals -3/2. Over here, we subtract 3. Divide by 4. M is -3/4. Those are your answers. And then you can put an or in between them. So these would look kind of weird on a graphing calculator. Like that's -1.5. And that's -3/4. Those are very close. And you're not going to see it that very well on the calculator. But there is a way that you can use the 0 key to help you figure those out. But we're going to do that later on. So in this one, step 1, set equal to 0. This is not equal to 0, so your first thing is to add 5. Now, where do you add 5 to? Do you add it to the x squared, the x term, or the 19? You add it to the 19 because they're like terms. So this is 0. And this is 24 if you add. Now we're going to factor because we have to split this x squared up. So we're going to split up the x squared into linear factors, x and x. Factors of 24 that add up to -11. Both your signs are going to be negative. I'll put the sign chart up here. So in this case, it's positive, negative, positive. So right here, it's positive, negative, positive is negative, negative. So we put two negatives in there, and then factors of 24, they're both going to be negative, so we can go negative 24, negative 1, negative 12, negative 2, negative 8, negative 3, negative 6, negative 4. These are all your factors of 24. Which one adds up to negative 11? There they are. So we're going to use 8 and 3. Set each factor equal to 0. You get 8 and 3. So like this thing right here can be punched into the calculator. You don't want to punch it in where it's equal to negative 5, but you can punch it in once it's equal to 0. So you can go to y equals and type in x squared minus 11x. And that was plus 24. Remember that, plus 24. And press graph. Now I'm still on that zoom 4 screen, so I'm going to press on to stop that. I'm going to press zoom 6 to make it a little bit bigger. Sometimes you even have to make it bigger than this screen. But that looks like 3 and 8. So it's 1, 2, 3, 4, 5, 6, 7, 8. 3 and 8. You can also look at the t-table. Let me set this t-table up though. It started at 0. Go by ones. Let's look at this t-table again. So you'll see at 3. Do you see there's a 0 next to 3? That's called a 0 of the function. And if you keep going down, there's the second 0 of the function, 8 and 0. So you can see t-table or graph. Again, there's the graph. Somewhere is the graph. There it is, 3 and 8. Or we can do it by factoring, 3 and 8. Okay? So here's the next one. We have to make sure that this right side is equal to 0, so subtract 5 from both sides. This is going to give you 10. So we're going to split up our n squared into n and n. Now what are some factors of 10 that add up to 7? Hopefully you're saying 5 and 2. 5 times 2 is 10. 5 plus 2 is 7. Set each factor equal to 0. And you get negative 5 and negative 2. Again, you can graph that on the calculator if you want. Number 7. Again, we do not have the right side equal to 0, so we're going to add 2 to both sides. And we're going to factor n and n. Factors of 24 that add up to negative 10. Both signs are negative because of this. Positive, negative, positive, negative, negative. Factors of 24 that add up to 10 should be negative 6 and negative 4. These would be the only ones even close to it, but those definitely add up to negative 10, so we're going to put in a 6 and a 4 here. So n minus 6 equals 0, n minus 4 equals 0, so n equals 6, and n equals 4 if you add 6 to both sides and add 4 to both sides. 6 and 4. So let's set this one equal to 0. Let's subtract 6. Factor, factor, get n and n. Factors of negative. Okay, so when you have a positive, positive, negative, when you have a positive, positive, negative, your signs are positive, positive, negative. Your signs are different. So factors of negative 18 add up to 3. This is not even right. Negative 9 and 2, 9 and negative 2, 6 and negative 3, 6 and 3. Which one of these adds up? Do any of these add up to 3? Those are your factors that add up to 3. 6 and negative 3. So put them in. Set each factor equal to 0. And then it's 3. So this one down here, we're going to subtract 6. Now this time these numbers are too big. You should always, anytime you have a number bigger than 1 here, you should see if there's a GCF. And there is a GCF. 6 goes in all of these, so you should remove that. Now we have easier numbers to factor. And since 6 doesn't have a variable, you don't even have to worry about this when you're solving. Because if it doesn't contain a variable, you don't even have to worry about it. So I'm going to write it down, but you're not going to set it equal to 0. So factor this trinomial now. We have n and n. Factors of negative 4 that add up to negative 3. Your choices are right here. Which ones add up to negative 3? it'd be negative 4 and 1. Now, we only set factors that contain variables equal to 0, so we're not going to use the 6. So n minus 4 equals 0, n plus 1 equals 0, n equals 4, n equals negative 1. So this problem, we're going to add 7 to the other side and write it in standard form. Means king, queen, commoners. Is there a GCF? Because this 7's too big for me. Take a 7 out. Oh, that was so much easier now. If you take a 7 out of each one, you get this. So we have 7 factors of r squared are r and r. Factors of 1 that equal 2 are definitely 1 and 1, and they're both negative. Positive, negative, positive. Negative, negative. So, you don't have to worry about the 7. This is the same factor, so do I really need to do this twice? No, it's the same answer. So add 1. R equals 1, R equals 1. So this is called a double root. Let me show you what a double root looks like. We're going to punch this in the calculator. Let me show you what a double root looks like on a calculator. See how this one, let's go back to that last one. So this one touches twice. It goes through the x-axis twice because a quadratic has 2 answers. What does it look like if it's the same answer? So I'm going to keep the, let's see, let me clear this. We have 7x squared minus 14x plus 7. I'm going to show you what a double root looks like. Remember, the answer was 1, twice. When it's a double root, it will just touch the x-axis and go back. It doesn't go through the x-axis. It touches it and bounces off. So that's how you can tell if it's a double root. It doesn't actually go through it. It actually touches it and bounces off. So that's what a double root looks like. Okay. Backside. So make each function, match each function with its graph. So 18. So these are matching, so we're going to factor this. Now you could just graph it. Let's just graph it. Heck, we'll just go the easy way. X squared plus x minus 6. What does it look like? That looks like choice A. So this is A. Now how would I, if I didn't have a graphing calculator, how would I know that? If this is a 2, a quadratic has 2 motions. See how this is down and up? That's 2 motions. That's a square. This one has 3 x's in it. 3. So it has to have 3 motions. So if you look at this, it goes up, down, up. That's 3 motions. Also, look at its roots. If you set that equal to 0, it has to cross the x-axis at 2. Do you see where it crosses the x-axis at 2 right here? That's a 2. See, this opposite of positive 2 is negative 2. See how this is crossing at negative 2? And then this one, the opposite of that is 1, and it's crossing at 1. So you can also tell by looking at its roots, where it's crossing the x-axis. So this one crosses 3 times. That's what cubic means. Cubics cross 3 times. Quadratics only cross twice. If you would have factored this, it would have been negative 3 and 2. Negative 3 and 2. So I'm going to show you on 19, if you graphed it on the calculator, that you would have got that graph. So you got x minus 2, parentheses x plus 2, and parentheses x minus 1. So we're going to graph it, and this is called a cubic function because there are 3 x's present, and do you see how it crosses the x-axis? 3 times, 1 for each of the x's. So this is graph B. And when you have to write a quadratic equation that's given negative 5 and 4's roots, you have to go backwards. So we're going to start by saying x equals negative 5 or x equals 4. That's our roots. And now we have to make factors. So to make factors, we have to make each of these factors equal to 0. So we're going to add 5 back to this side, and that makes that x plus 5 equals 0. That's one of your factors. On this one, we'll subtract 4 from both sides. And that's your second factor. So then you can multiply these two and set them equal to 0. There's your double factors. And then this is good enough for an answer, but if you FOIL it, that's the best. So you get x squared minus 4x plus 5x minus 20. For this. This is your quadratic equation. Oops, I didn't show any of that work because I had it off the paper. So add 5, subtract 4, get these factors. Then take this factor and take this factor, set them equal to 0. And then FOIL, x squared minus 4x plus 5x minus 20. Add these two for an x. This is your quadratic function. If you punch that in the calculator, to double check it to make sure you did it right, x squared plus x minus 20. And it crosses at -5 and at 4. So that just double proves to you that you did it right. Okay, that's it.